Hi class, this is section 6.7. This is the last section of chapter 6 that we are going to talk about. And it involves yet another formula that you're going to have to know. So it is finding the arc length of a piece of a circle. So yesterday we talked about the circumference of a circle, which is the length all the way around the circle. But what if you just want a piece of it? So like if we're looking at this picture right here, what if I just wanted to know the length of AB? Not the measure of it, but the actual length. And of course that would change the larger the circle was and according to what the radius of the circle is. So let's open up Sketchpad and do a little investigation. So let's start with a circle and let's make a central angle. Okay, so there is a central angle. We already know how to find the measure of the angle. We could either measure the central angle and know that this arc is equal to that length, or we can highlight the two endpoints in the circle and say measure arc angle. So that's the degree of the arc. And we know it doesn't matter the size of the circle, that I'm changing the degree of the angle here, but it's always just a percentage. The whole circle is 360. Okay, so this is doing, it'll go to 180 and then go back to a minor arc. Okay, so we have talked about that this whole chapter. What we haven't discussed is what the length of arc CB is. So if I highlight the 2 points for my arc in the circle and say measure, my second option there is arc length. So there is the length. If we could take a ruler and measure it, that's what we would get, 7.67 centimeters. But because it's curved, we don't have that option of using a ruler. So the question is, how do we come up with that number? So there is a formula for it, and I'm going to show you what that is. So what I want to do is take the arc degree measure. I'm going to open my calculator, and I'm going to put this in parentheses, and I'm going to divide it by 360, because that will give us what percentage of the circle that we have. And I'm going to hit OK. So it is 0.27 of the whole circle. Now if I take that number and I multiply it by the circumference, it should give me the length. So I need to calculate what the circumference is. Okay, so I'm going to go back to my calculator and take this value that I've already found and say times the circumference of the whole circle, and I get that length, 7.67 degrees. Okay, so that is how you're going to calculate what the length is. So let's review that. You take the degree measure and divide it by 360. That just gives you a percentage of the piece that you're trying to measure. If you multiply that by the circumference, which would be the whole circle, but we only want this little piece of it, it'll give you the length of your arc. Okay, so let's go back to our notes and complete the conjecture. So the length of the arc equals the degree measure of the arc divided by 360 times the circumference of the circle. Remember, you find circumference by taking 2 pi r, or the diameter times pi. Get rid of that. Okay, so the degree measure of the arc divided by 360 times the circumference of the circle will give you the arc length. Okay, here's an example. If the radius of a circle is 24 centimeters and the measure of angle BTA is 60 degrees, what's the length of arc AB? So you need to know the degree measure of arc AB, and because this is an inscribed angle, you double that to get the arc. So arc AB is going to be 120 degrees. So we divide that, 120 divided by 360, and when we do that, we get 1/3. So as you can see here, they've got that right there. That is the degree measure divided by 360. So the length is 1/3 of the whole circumference all the way around the circle. So that's 1/3 of the whole thing. So you take 1/3 and multiply it by the circumference. They gave us the radius to be 24. So circumference formula is 2 pi r. So 24 times 2 is 48 pi. So the arc length is 16 pi centimeters. And of course, you know, I don't like it to approximate pi, so I would leave the answer as 16 pi centimeters as the length. Okay, one other thing we're going to talk about in this section, it's another mini investigation, which we've done several of these. What happens if the measure of the angle formed by the intersecting tangent is with a secant line? So we've got a tangent and a secant. But this is going to work the same way as our last conjecture did. So we're going to take this big arc minus the little arc and divide it in half. So let's go to Sketchpad and do that. So let's start with the circle. We want to construct a tangent. So I am going to make the radius, and then I'm going to highlight this point in the segment and say construct a perpendicular. That is my tangent line. So now I need to make a secant line. So I'm just going to pick any point on my tangent. I'm going to pick another point on the circle. I am then going to construct a segment. So now I have a tangent and a secant. Secant line passes through a circle at 2 points. I'm going to hide some of these things here. Okay, so there's my tangent, there's my secant. I'm going to make this a point here, this other intersection point, so that I can measure the arcs. So I'll highlight these 2 points with the circle and say measure arc angle. I want the degree measure, and then I'm going to come around here and highlight AB and highlight the circle and say measure arc angle. So if I want to know the measure of this angle that's formed out here by the tangent and by the secant, if I take the larger arc, which in this case is arc DB, and subtract the smaller arc, which is arc AB, I need to put parentheses here. If I take the difference and then divide it by 2, I will get the measure of my angle out here. Now let's just make sure. So I'm going to highlight the angle and measure it. And it is indeed the same. So angle DEB, which is formed by a secant and a tangent, is equal to the larger arc minus the smaller arc divided by 2. So let's complete our notes. The measure of the angle formed by an intersecting tangent and a secant to a circle is 1/2 the difference of the larger intercepted arc and the smaller intercepted arc measure. Okay, and this concludes our lesson today. I will see you in class tomorrow.